Lastly, let's take a look at how we can draw conclusions from studies. Sample surveys can only draw conclusions about the population from which the random sample was selected. Suppose a survey conducted on randomly selected college students from Texas. We can only use those results to draw conclusions about college students from Texas, specifically those people. We can draw the conclusion about all the college students from Texas, but we cannot draw conclusions about all college students everywhere, nor can we draw conclusions about all people from Texas, or even more specifically, all college students from Louisiana, because those were not the population studied. The population studied was specifically college students from Texas. Now, when we're drawing conclusions, we need to consider how the experiment was controlled, and we have to carefully consider the differences between correlation and causation. A control group is often used to establish a causal relationship. Control groups give us a baseline that we can use to compare to the other groups. Correlation does not equal causation. Correlation is a relationship or pattern between values of two variables. There are a lot of things that are correlated that have very little relationship to each other. For example, if you look at the average stock price of Lululemon Corporation, and you look at the average family expenditure on bacon for those related years, you find that as bacon expenditure goes up, the stock price of Lululemon also goes up. There's a correlation between those two. But just because there's a correlation does not mean that one thing causes the other. A rise in the amount of bacon consumed does not necessarily lead to a rise in the stock prices of Lululemon. Causation is when one event does indeed cause another. So, in order to determine causation, researchers and experimenters have to be very careful to control the experiment for any confounding variables. Control groups, again, are how we use to kind of help establish that baseline. It's a subset of the participant or subjects that do not receive the treatment of the experiment. It establishes a baseline standard where we can make comparisons. Often control groups are given a placebo, which can be a substance with no therapeutic effect, generally a saline solution or a sugar pill. To test the effectiveness of a new cold medicine, participants are randomly assigned two groups. The treatment group receives the medicine and the control group receives a placebo. If we did not have a control group, in the medicine, we measured the results and found that, on average, participants got over the cold in 3 days. Without a baseline, we don't know how effective that medicine is or even if it worked at all. But by adding in a control group, and we see that the medicine helped those in the treatment group get better in 3 days, but our control group took an average of 7 days, then we can draw a strong evidence that the medicine is effective because it helped them get over the cold faster than those who did not use the medicine. So let's take a look at how we can draw conclusions. Youth Activist Group surveyed a random sample of 500 teenagers between the ages of 16 and 17. So there's our population. We have a sample of 500 teenagers between the ages of 16 and 17. That's our population. So any conclusion can only be based off of that population. The survey showed that the majority of those sampled were in favor of lowering the voting age. Based on the results, which of the following populations are most likely in favor of lowering the voting age? Well, when we look at all adults, that is not part of our population, so it can't be that. Registered voters, again, not part of our population. But 16 and 17-year-olds, that is our population that's being studied, and where our sample was taken, that's going to be our interested group. A study conducted to determine if a new treatment is successful in treating insomnia. 500 participants were selected at random from a large population of people with insomnia. So again, there's our population. Half the participants were randomly received a treatment, while the other half did not. The resulting data showed that participants who received the treatment slept better than those who did not. So we have to think, a group of people received a treatment was given to people with insomnia. So any conclusions have to be based off of the information given there. So we take a look at our options. The new treatment is likely to improve the sleep of anyone who undergoes it. Well, anyone is that important distinction there. We only tested it on people with insomnia, so we know that's not going to work. The new treatment is better than all other treatments in improving the sleep. Well, we only tested one treatment, a treatment. We didn't test any others, so we cannot make that claim. A treatment is likely to improve the sleep of people with insomnia. Well, that's what was shown. We tested it on people with insomnia, and it showed that they slept better. So we can make that claim.